Hello everyone. I am Saurabh Kumar and welcome to this project walkthrough where I'll demonstrate how I built an email spam detection web application using machine learning and Flask. This project integrates front-end and back-end development with a trained ML model to classify emails as either spam or safe. The main goal of this project is to detect whether a given email message is spam or not, based on its content. It combines machine learning, data preprocessing, model optimization, and web integration to deliver a seamless user experience. Let's first take a look at the tools and libraries used in this project. Python, the core language for the backend and ML model. Flask, a lightweight web framework used to create the backend API. Pandas for data handling and preprocessing. NumPy for numerical computations. Scikit-learn for building and optimizing the machine learning model. RandomForestClassifier as the primary ML algorithm. GridSearchCV for hyperparameter tuning. SMOTE, synthetic minority oversampling technique to handle class imbalance. Course, cross-origin resource sharing, to enable front-end-backend communication. The dataset used contains thousands of email messages labeled as spam or safe. Using Pandas, I loaded the dataset and performed key preprocessing steps. Removed null values. Converted all text to lowercase. Removed punctuation and stop words. Tokenized and vectorized the messages using TfidfVectorizer, which converts text into numerical features. I also noticed a class imbalance, where safe emails outnumbered spam emails. To fix this, I used SMOTE, which synthetically balances the classes by generating minority class samples. I used the RandomForestClassifier, which is robust and performs well with text data. I applied GridSearchCV to perform hyperparameter tuning, testing different combinations of n_estimators, max_depth, and min_samples_split to best performing model. Now, let's move on to the backend development. I created a Flask app in app.py. Here's what it does. Loads the trained ML model and the TfidfVectorizer. The dataset was split into training and testing sets, typically an 80-20 split. The model was trained using the training set and evaluated on the test set using metrics such as accuracy, precision, recall, and F1 score. Accepts a post request from the frontend with a user-submitted message. Transforms the input text using the vectorizer. Uses the model to predict whether it is spam, 1, or safe, 0. Sends the prediction back as a JSON response. To start the backend server, I simply run Python app.py. To make the interface visually engaging, I added a custom particles animation background using Canvas and JavaScript. This creates a parallax particle effect based on mouse movement. Robust error handling has been implemented. If the server is unreachable or returns an error, a friendly message is shown to the user, and the console logs the technical error for debugging. Based on the result, if it's spam, the frontend displays, "This email is classified as spam." If it's safe, it shows, "This email is classified as safe." The result is shown dynamically, and both the result and input box are cleared after 5 seconds. This project demonstrates how machine learning can be used in real-world applications like spam detection. Future enhancements could include adding support for attachments or subjects, improving accuracy with deep learning models, hosting the app online using platforms like Render or Heroku.
Thank you for watching this project demo. I hope you enjoyed this walkthrough.